So this year, before September, a star in the constellation of Corona Borealis will explode, and in the northern hemisphere, we'll be able to see it with the unnaed eye. The star is T Corona Borealis, a white dwarf star. 3,000 light-years away from our solar system, it will turn into a nova, which we'll discuss a bit later in spring or summer. Even though this occurrence is predictable happening every 80 years, is still a once-in-a-lifetime event. If you're human, T Corona Borealis is not your regular star. It's actually a binary, two stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two, but the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. You see, in astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower. The number assigned as a magnitude is just like golf. Low scores, in our case, it means that we'll be able to see the star with the unnaed eye, even in light-polluted skies. Now we can only see the binary with binoculars in a completely dark sky. After the outburst, T Corona Borealis will remain the brightest star in the constellation of Corona Borealis for a few days before gradually dimming. Now, this event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun, instead of disappearing in a blinding flash of light forever. T Corona Borealis will experience a nova, an explosion on its surface, flinging matter into space, but not ruining the star itself. Such recurrent novas happen at regular intervals. T Corona Borealis was known to astronomers from the past as the Blaze Star. Last time it exploded in 1866 and 1946. Astronomers from NASA believe it's going to do it again before September. This year, the constellation of Corona Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go to Arc to Arcturus, finding the bright star in the Buddhist constellation. Due east, if you go diagonally down to the east-northeast horizon, you'll spot Corona Borealis now. If you want to observe the brightening of T Corona Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you'll be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. Now, an NOA is a short-lived sudden explosion involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star. So close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface. And then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 nova happen every year in our galaxy, but not all of them are noticed. NASA's fiery Comet Space Telescope has observed several nova that occurred not far on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about a novae, it's time to discuss something much more dramatic. Supernova. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hara of an extinguishing massive star. It happens to stars at least 5 times the mass of our side. Once they near the end of their lives, they go out with a ginormous bag. Huge stars burn incredible amounts of nuclear fuel at their core, producing tons of energy. It makes their centers immensely high. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between two opposite forces. Its gravity attempts to squeeze the star into a teeny tiny ball, and the nuclear fuel burning at the core of the star produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off. Its pressure drops and gravity wins. The star collapses, an enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. Also, there's another type of supernova. It usually happens in systems where two stars orbit each other. And at least one of these stars is a white dwarf the size of our planet. If such a star collides with another or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernova are often so bright, they can outshine the combined light of entire galaxies for several days or even months. Supernova aren't common, astronomers. Think just a few of them occur within the century. And galaxies like our home, Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernova every year outside our galaxy. Unfortunately, space dust blocks our view of most supernova happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019. But it wasn't the event we expected to see. The star is found in the constellation of Orion and is huge, so big that if we moved it to the center of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth. Even during the day, this explosion could happen as soon as tomorrow, or as far-flung as hundreds of thousands of years from now. So don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show. But instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that, because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material. From the surface of the star, events like this occur on the Sun all the time, especially when our star's activity is high. Bits of the Sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They don't harm our planet, but they can mess with satellites and electrical equipment. Now, getting back to Betelgeuse, we've never seen such a huge mass ejection on the surface of a star before. It's a new phenomenon which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the hidden info secrets.